The engine coolant temperature sensor, also known as the ECT sensor, is a thermistor-based device that monitors your engine's coolant temperature. It's typically located near the thermostat housing in the engine compartment. The sensor sends voltage signals to the engine control unit, which uses this information to adjust fuel injection timing, ignition advance, and cooling fan. In essence, it helps your car's computer know if the engine is running hot or cold, which affects how it runs. A bad CTS can manifest in several ways. Look out for erratic temperature gauge readings, such as sudden overheating or the gauge not moving at all. You might also experience poor fuel economy, black smoke from the exhaust. A check engine light, often with codes P015-P019, engine stalling, or reduced performance. In modern vehicles, a faulty CTS can even trigger limp mode to prevent engine damage. Pay attention to unusual behavior to catch a failing sensor early. Several factors can cause a CTS to fail. Corrosion due to contaminated coolant is a major culprit. Corrosion occurs when coolant becomes contaminated, particularly from mixing incompatible types, leading to sensor degradation. Electrical shorts often result from damaged wiring or harness issues, causing sensor malfunctions. Extreme heat cycles can degrade the sensor, reducing its accuracy and shortening its lifespan. Less frequently, manufacturing defects or physical impacts from road debris can cause sensor failure. Regular coolant maintenance is essential to preventing corrosion-related CTS failures. If you suspect a bad CTS, start with an OBD2 scan to check for trouble codes. Next, visually inspect the sensor and its wiring for any signs of corrosion or damage. Check your coolant levels and quality. Is it clean and at the proper level? These basic checks can often point you in the right direction before diving into more complex testing. Testing the CTS with a multimeter helps verify if the sensor is working correctly. First, disconnect the CTS from the engine. For safety, disconnect the vehicle battery beforehand to prevent electrical issues. Set your multimeter to the ohms mode for resistance measurement. Connect the test leads to the sensor terminals. Measure the resistance at room temperature, which should typically be 200 to 300 ohms. As temperature increases to about 100 degrees Celsius, resistance should decrease to 30 to 50 ohms. Compare your readings to the vehicle's manufacturer specifications. If the measured resistance significantly deviates from these expected values, the CTS is likely faulty and should be replaced. Basic troubleshooting can be done at home with simple tools. You can perform OBD2 scans and use a multimeter to test sensor resistance. Professional mechanics use advanced techniques like oscilloscopes to analyze the sensor's signal accuracy and waveform patterns for a more precise assessment. If you're not comfortable with electrical testing or interpreting sensor data, it's best to consult a qualified technician. Proactive coolant flushes every 30,000 miles can prevent 80% of CTS failures by avoiding corrosion. This simple maintenance step uses compatible coolants to keep the sensor and system clean. Current trends include sensors made from durable ceramics, reducing failure rates by 10% compared to older designs through better heat resistance. IoT integration allows CTS to communicate via CAN bus for predictive maintenance, with AI diagnostics potentially reducing misdiagnoses by 30%. While electric vehicles replace traditional CTS with thermal management systems, the sensor remains essential for the 70% of vehicles still using internal combustion engines. Looking ahead, solid-state sensors promise increased accuracy and longevity up to 200,000 miles, extending far beyond current designs.